As we continue our discussion on financial management, we now look at the concept of diversification and try and use it in a portfolio of two stocks and try and understand what is the impact of having a couple of stocks with different correlations, in the portfolio, and try and see what happens to the portfolio variance and what is the learning from that entire discussion that we have, right? For the purpose of this discussion, we're going to assume that there are two stocks in the portfolio, and these two stocks have different proportions, and what is going to happen at the variance at different weightages. That's what we're going to look at. Let's assume stock 1 has a monthly return of 1.75% and a standard deviation of 9.73%. Let's say stock 2 had an average return of 1.08 and a standard deviation of 6.23. Correlation is 0.37. How will the portfolio of these two stocks perform, right? Now, we know that expected return of the portfolio is nothing but weight of stock 1 into return of stock 1 plus weight of stock 2 into return of stock 2. So that's straightforward. We can calculate that, whatever weights we use, right? Now, variance of the portfolio, sigma p square, is given by weight of 1 square, sigma of 1 square, plus weight of 2 square, sigma of 2 square, plus 2 into weight of 1, weight of 2, sigma of 1, sigma of 2, and correlation between 1 and 2, right? So we have all the values with us. We can try and calculate this and try and understand what happens to this portfolio. So for the calculation purposes, we're going to use various weights where weight of 1 is going to vary from 0, 25%, 50%, 75%, and 100%. And obviously weight of the second stock will then become 100%, 75%, 50%, 25%, and 0% in the portfolio. So we're going to look at these combinations and try and identify what is going to be the portfolio variance and what is going to be the portfolio returns, right? So let's go to an Excel file. So that's our Excel file that has the data available with us, and the data is stock 1 return, stock 1 standard deviation, stock 2 return, stock 2 standard deviation, and correlation coefficient. Weightages are given to us. Can we calculate the portfolio variance, portfolio standard deviation, and portfolio return, right? Let's first calculate the variance. That's going to be standard deviation squared. So that's my variance number, 0.95 square, and I'm going to find the variance for the other one, which is 0.39 square. So variance for stock 1 and variance for stock 2 has been calculated. What have we done? We have just taken the standard deviation, whatever is the standard deviation, and we have squared it, right? Now remember the formula. Formula is weight of 1 square sigma square, right? Then to this we add weight of 2 square sigma 2 square. Remember, these are variances, so plus, and then we add 2 into weight of 1, weight of 2, sigma of 1, sigma of 2, rho 1, 2. That's the formula, right? Let's try and calculate that. So our term, I'll put a bracket, and let's probably increase the font size a little bit. So this would be weight of 1 into weight of 1, that's weight of 1 square, multiplied by sigma of 1 square, that's the variance of stock 1, correct? And that variance of stock 1 will always remain constant, so I'll freeze this by adding dollar signs, then do plus weight of 2 into weight of 2 into sigma of 2 square, and we freeze that as well. So that takes care of the first two terms, right? And now we look at the third one, that is in a bracket 2 multiplied by weight of 1 multiplied by weight of 2 multiplied by sigma of 1, freeze this, multiply by sigma of 2, freeze this, and multiply by, sorry, sigma of 2 is actually given here, B7, freeze this, and multiply with the correlation coefficient and freeze this, right? Why have I frozen only the standard deviations and variances and correlation? Is because when we drag it down, we would want the portfolio weightages to change, but we don't want the other values to change, right? So that's the formula. Let's look at this carefully and closely. We have weight of 1 square, that's A11 into A11, that's here. Then sigma of 1 square, that's the variance of stock 1. Then we have weight of 2 square, that is B11 into B11, multiplied by sigma of 2 square, that's variance D7 for stock 2, plus 2 multiplied by weight of A into weight of B into sigma of 1, which is now the standard deviation, sigma of 2, which is the standard deviation of the second stock, and correlation between these two. So that's the term that comes here, right? So that's our calculation, and we can press enter. We get portfolio variance as 0.39%, right? That's the portfolio variance. Can I control this, copy this, and paste it as formulae? Okay, that gives me the portfolio variance at different levels of portfolio weights, correct? That's the portfolio variance at different level of portfolio weights. If I calculate the square root of this, that's going to give me the standard deviation. And if I calculate the portfolio return, that's going to be 0% multiplied by stock 1 return, freeze that, plus 100% multiplied by stock 2 return, that's this, freeze that, enter. I can copy these, I can drag this down, and I can select this, Control C, and paste it as formulae. Select all this, paste it as formulae. Right, so that gives us the values that we were looking for. Just going to reduce the decimal points here. We can erase the drawings, and now when we look at this in detail, what is it that that we see here? We find that based on different weightages of the stock, we have been able to calculate the variances of the portfolio. Taking the square root of the variances, we have arrived at the standard deviations of the portfolio, and subsequently we have also calculated the portfolio return, right? So you see portfolio return keeps increasing, but the same is not true for variance. Variance actually goes down, then goes up again, right? So from 6.23%, when you have 100% of stock 2 in the portfolio, the portfolio variance is going to be the same as the portfolio standard deviation is going to be the same as stock 2 standard deviation. When you have 100% of stock 1, then the portfolio standard deviation is going to be the same as standard deviation of portfolio of stock 1. At varied combinations, depending on what the correlation coefficient is, we're going to find various standard deviations, right? Now let's see this in more detail. What we have here is that we find that as we increase the weightage of stock 1, at some point the portfolio variance goes down and then it again starts going up, right? So there must be a particular weightage of the two stocks where we are minimizing the risk, right? Let's actually plot these two on a curve. So we're going to select this data. We're going to insert a chart, and in the chart we're going to use a specific kind of chart which is called as XY scatter. We're going to use XY scatter. So when you select XY scatter, we could select any of these points, and let's select the third one here, and I'm going to select this portfolio return chart. I'm going to click OK, and this is what we find. Now when you look at this, on the x-axis you have the standard deviations plotted. On the y-axis you have the returns plotted. So as you keep changing the weightages, there is one point here. There is some point here where you're going to minimize the risk in the portfolio, right? There is one point here where you're going to minimize the risk of the portfolio, and that's possibly going to be the point where you have the best risk adjusted return for the portfolio, right? Now we'll get into more details about this as we go along, but that's how you basically make a plot. I'll just move this down